way back to your
I think
freshman
I
year
remember.
of Algebra 1. Anybody remember what function means?
It's the F. It's the F one.
Okay, f of x is something, right?
Yes.
Okay, good. Let's talk about that today. Here is the extremely wordy version of what a function is. Okay? A function means there's a relationship between variables such that for any input, there's only one output. For each independent variable, there is at most one dependent variable. So for each x, there's only one y. I'm going to give you a second to write that down, and then let's see if we can come up with a different way to say that. Because that's the really, really wordy version. So how else might we say that? Instead of this really long thing, what else might we say to help you remember what function notation is? What do you guys think? How could we take that and condense it into just a couple words or a phrase? What could we take out of that maybe to make it simpler? Any ideas? What do you think, Zeb? You just got your notebook out. Well, you keep looking up. I thought, oh, Zeb's ready. How about just the part that says for each y, or for each x, there's only one y? For every x, only one y. That is the essence. So it's only a function if there's for every x, there's only one y. Okay, let's see what that means. Okay, so you could do a function test to see if there's only for every one x, there's only one y. You would draw a graph, and on your graph, if you could draw a vertical line, and it only touches the graph in one spot, it is a function. So on that first one right here, if I could draw my line here, or here, and since it only crosses my graph line one time, it is a function. On this middle one, if I draw a vertical line, it touches it in two spots. So it cannot be a function because when x is 2, y is 2, and y would be 4 or 5. So therefore, I do not have one x value for one y value. I had two x values with the same y value. So it has to be a one-to-one correspondence. Same thing, if I'm looking at my table, on my calculator, on my XY chart, if I had x's, let me zoom out for you a little bit. If I had x is -5 and y is 0 and -4, -3, -2, -1, so on and so forth. And at any time, if y equals 0 again, it is not a function because it crosses that twice. Okay? So you can look at the graph or you could look at a chart. How about this other graph right here? Would that be a function?
Yeah.
Yes, because again, a vertical line only crosses it one time. I think that one's the most confusing because people look at that, and if you were thinking horizontal line, it would cross it, but don't think horizontal line, think vertical line. okay? Vertical line has to cross at one time for it to be a function. If it crosses more than once, it is not a function. Any questions on that part?
I don't get what you're like.
What I'm saying with that?
Yeah.
Okay, let me
Well,
grab,
it looks like it touches it more than once.
for this graph right here?
Yeah.
Nope. Let me, let's draw a new one. Okay. Here's my x, y. And this is my graph, okay? I need to look and see if I have any vertical line. Vertical meaning up and down. So, look at my straight edge here. If it only crosses this graph line at one exact spot, it is a function. So when I put this vertical line here, it only touches it at that exact spot right there. Do you see that? So if my vertical line was here that I had graphed, or that I'm looking at, it only crosses it right here. There's no other spot that this graphed line crosses the vertical line. I could draw a vertical line at any spot, and it only crosses at one time. Whereas if I had this graph, I had, let's see here. That too would only cross one time, right? What about this one? That one is not a function because when I draw my vertical line, it crosses here and it crosses here. Okay? So the vertical line can only cross one time. For every x, there's only one y. So when you look at a table, if any of the x values are shared or any of the y values are shared, it's not a function. And in your book, they're going to give you tables like that, and they're going to say, okay, looking at this table, is it a function? Tell me why. Why is that not a function?
One is 6 and one is 8.
Because x, where 1 is 6, you also have 1 is 8, so it's not a function, okay? So really, when you look at the words, it's a complicated thing, but if you look at a table or look at the graph, it's not so much, okay? Let's look at this one. Would this one be a function? Would that one be a function? No, why?
There's 2 5s.
Because you have 2 5s. Okay, so you have to have 1x to 1y. Those numbers are only going to be used one time. Okay? How about review of domain and range? Do you remember that? That for domain equals all x values. And range equals all your y values.
I thought the range was the difference between the maximum and the
Range, when we're looking at statistics is, but when you're looking at graphing something, it has another meaning. It means all the y values. But if you think of it this way, Amelia, that all your y values is a set of numbers from max to min. So, dual purpose. Yep. Domain though is all your x, and range is all your y. So this would be your domain here, and this would be your range here. take a look at an example. When we talk about function notation, and we write it like this, y equals f of x. So it doesn't matter if you say y equals an equation, or if you say f of x equals an equation. It means you're solving for something, okay? So y can be used interchangeably with f of x. When you see f of x, it means you're solving a function where x is a specific value, okay? That's what f of x means. That you're solving a function where x is a specific number or value. So, if they say y equals 3x plus 1, you're solving something when you have an x, right? If they say f of x equals 3x plus 1, these mean the exact same thing. I could put f of x here, or I could put y here. The only difference is when a function notation, they're going to tell you what they want you to find for x. They might say f of x for all numbers between -2 and +2, or they might say f of x where x equals 3. Okay, so it helps you limit it a little bit more. So let's take a look at this one right here, where we have f of x equals 3x plus 1. And I want you to look at this and say, okay, well they might say f of 2. So solve this when you have f of 2. So all I do is put 2 in where x is. So 3 times 2 plus 1, which gives me 7. That's all that means. Let's take another look at the next one. Okay, so if they say f of x equals 2x plus 5 over x minus 3, and find f of 2, you're going to plug in 2 for every part of x. So I'm going to rewrite this equation. F of x, where x is 2, so I'm going to say 2 times 2 plus 5 over x minus 2. Oops, sorry. X minus 3, and I forgot I was plugging 2 in there. So on the top I have 4 plus 5. On the bottom I have 2 minus 3, which is -1. So 9 over -1, which is -9. If I had said f of 3, then I would have plugged in 3 for both of the x's. If I had said f of 10, 10 goes in where both the x's are. Okay? Any questions on that? Pretty straightforward, right? Okay? All right, let's take a look at this next example real quick. No, it's pretty small, so I'll zoom in on that one for you. Okay, so another one would be if you had f of x equals x squared plus x plus 1, and they tell you to solve where f of 3. I'm going to plug my 3 in wherever the x is. So instead of x squared, I'm going to have 3 squared. Where I had a plain x, I'm going to have a 3 plus 1. So 3 squared is 9, plus 3 plus 1, and f of x is now 13. Do you want me to zoom out on this entire page?
Yes.
Okay. Where'd you get 5 from? I'll give you a minute to write that down. Do we have any questions?
Yeah. The last one, it's f of 3, right?
Yes.
How come you put 5 squared?
that is Mrs. Rumsey's handwriting, it's a 3.
Oh.
It's a 3.
Well, it's supposed, oh, it really is a 3.
It really is a 3.
I thought she made a mistake or something.
No, it's a 3. These are the same notes she's been using for like, I don't know, all 17 years maybe of teaching. No, not that long. So, we try to make one set of notes and then use them as much as possible. Yep. You can probably stop teaching Mrs. Thompson.